the PowerPoint itself is not mine, it's from Stats Day that was for all of us teachers telling us about this new stuff. So you've got the same sort of slides that we dealt with. So I'll skip through stuff that's just for teachers. Yes. Okay, here we have some true headlines. Bacon increases your risk of colorectal cancer by 20%. 1 extra unit a day increases a woman's risk of breast cancer by 12%. 2 units a day reduce the risk of heart disease by about 17%. Now, what all of these are doing is talking about relative risk, not actual risk. So it's kind of a bit of a trick in the, almost scaremongering. It doesn't actually mean anything unless you know what your actual risk is. Because relative risk is quite different. So what do we mean? It's to do with situations that are generally bad, sometimes good, things happening. Mainly use our gut feelings to deal with these situations and make decisions. These feelings can be influenced by experience, emotion, media, etc. Okay. 2 main brain systems. I don't think we want to go into that, or that, or that. We want to go to here. So what we're looking at is bacon increases your risk of colorectal cancer, sounds horrible, by 20%. So about 5 people in 100 get the cancer in a lifetime. So that's your actual risk, 5 out of 100. And so reducing it by 20%, so 20% of those 5 people becomes then 4 people, right? So then you get 4 people. Increases, I went the wrong way. Increases by 20%, so 20% of 5 is 1, so we add 1 person on. So if your risk is 5 out of 100, it's just gone up to 6 out of 100. Okay? So would you or would you not then carry on eating bacon? No. No? Depends how much you like bacon. Okay. With alcohol, what's our actual risk? 1 unit of alcohol increases a woman's risk by 12%. So about 10 in every 100 women have breast cancer in a lifetime. That's 1 in 10. What? I don't want to know that. 1 extra unit of alcohol increases by 12%, so that becomes 11 out of 100. About 1, you're raising it by 1%. Okay? So 12% sounds like a lot, but it's actually only changing your risk. You're adding another percent to it. So you can see the difference now? There's 1 nod. Anyone else see the difference? Is it becoming any clearer? Yay or nay? This is still not clear? The whole concept of risk.
Is absolute risk just something that could just happen to anyone? But then relative risk is if you do something this would happen?
Yeah, so your absolute risk is looking at sort of the whole population, so your risk of getting it. The relative risk is comparing the change of that risk. Okay, so if my risk is 1 in 100 and I double my risk, I'm doubling the 1, so then it goes up to 2 in 100. So if I said my risk of getting some weird cancer was 1 in 1,000,000, and you said to me, your risk increases by 500% if you jump up and down on the spot for 5 minutes. Okay? So the 1 in 1,000,000 becomes 5 in 1,000,000.
So
You know?
the first one absolute risk and the second one relative?
Yeah, so the absolute risk is your risk of getting it, and the relative risk is comparing the risk of getting it with some kind of a treatment or not with the treatment. One kind of any of these statistics, it's really, we've done a few internals where there could be a lurking variable. Like, is it the drinking of the wine that causes the problem, or is it it says alcohol here, but does it matter what sort of alcohol you drink? Does it matter when you drink it? And I mean, the biggest thing I think with breast cancer is probably genetics. So different people don't have the same risk due to genetics. So, yeah, it's not exact science, if you like. So here we have another one where 2 units of alcohol a day reduce the risk of heart disease by 17%. So about 32 in every 100 women have heart disease in a lifetime. This is not pleasant. If all 100 drink roughly 2 units of alcohol a day, that falls to about 27. So, to drink or not to drink, if I drink, I'm more likely to get breast cancer, but less likely to get heart disease. It's all a bit tricky. Okay, depending on the story. So 20% or 12% can equal 1 person, while 17% can be the equivalent of 5 people. Don't think percentages, think real people. Okay? Because the percentages are tricking you, because it depends on what the absolute risk is, what those percentages mean, because we're comparing the absolute risk sort of in 2 different categories, if you like. Okay, so here you have double your risk. Risk goes from 1 in 1,000 to 2 in 1,000. How much has the relative risk increased? 1 in 1,000 to 2 in 1,000, the relative risk is actually increased by how much percent? 100%, yeah, it's doubled. But you can see here the 1 in 10, that's 10% to 20%. That double risk makes a way bigger difference in the number of people who are going to get it. Whereas the 1 in 1,000 to 2 in 1,000, we're only having 1 person in 1,000 being affected. Whereas here we've got, how many people in 1,000? If we've got 1 in 10 being effective, we've got 10 in 100, we've got 100 in 1,000. So that top one is 1 person in 1,000, and this one is 100 people in 1,000. Okay? That's a nice one, that one. I like it, that you can see visually. So I think that's 1 in 1,000. So the background risk is no coffee, and the blue person is the additional risk with coffee. So that's only looking at one particular risk. Okay, 1,000 people. We'll see if we can Google that. It looks like a really good tool. And so here we've got quite a different picture, haven't we? So I think this relates back to what we were talking about. Okay, so the 1 in 1,000 to 2 in 1,000, that's what's happened. The red one is the 1 in 1,000, the red and the blue is the 2 in 1,000. Here was the 1 in 10. So that's your 1 in 10 is the red, and then doubling the risk affects that many people. Is that making more sense? Okay, so there we have the comparison. Both of them are doubling the risk, but when you think in terms of people, it's quite a different picture. Still frowning? Are we all good now? Hands up who's still good. Good now on that. That helped. Excellent. Okay, we'll just skip through the rest of these lovely slides. I've put that on the Google Drive for you so you can look at it. So there's a lot more there that you can look at home. Does that make sense? You've got these formulas, but sometimes just working it logically works better for some people. It is actually just pure logic. And if you start trying to use the formula, sometimes you can just actually confuse it. But it depends on you. So do what works for you. Okay. Okay, so I've gone now to that website, riskcom.com, and I'm looking for the 1,000 people one.